Hello everyone, I hope everyone's Thanksgiving break went well. Probably too short, I'm sure. It was for me. I had some requests to go over EKGs or ECGs as I put it on here. Either one is fine, you can call it either one. So we will go ahead and do that on a little video so you guys can all be equally prepared for this on the practical. But first we are going to start off with some definitions to make sure that all of us are on the same page. I do want to mention that this will just be a very basic explanation. We'll only go through the few things that I think that will be necessary for you guys on your practical. But first off, let's go over these definitions. The first one I want to go over is systole. So please to yourself, ask yourself, do you know what systole is before I pop up the definition? To put it pretty plain and simple, systole for us is going to be a period of contraction within the muscular tissue inside of the heart. Of course, similarly, we want to go ahead and think about what the definition is for diastole. Diastole is, of course, the opposite. It is the period of rest versus contraction inside of the heart. And I did want to go ahead and bring up this third party. Go ahead and ask yourself what asystole means to you. Asystole is commonly referred to as a flat line, meaning on an ECG or EKG, you would not see any sort of wave upwards or downwards. If you have asystole, that is a shockable situation. It means that the heart is not contracting and you are essentially dead. Asystole is going to bring us into the visual of the EKG, but a reminder that the atria are on the top of the heart, the top chambers of the heart, and the ventricles are on the lower part. This will be helpful for envisioning what is going to happen during the steps of the EKG. At the top of the screen, we have an image of what your EKG or ECG should look like, ideally. This is called normal sinus rhythm. If it is faster and you are having a lot of heartbeats, that is called sinus tachycardia. If it is slower, it is called sinus bradycardia. But this is what your EKG should look like whenever you are looking at the screen. Go ahead and ask yourself if you can remember what the names of these individual peaks in the EKG or ECG are called. The first noticeable bump on the EKG is called the P wave, and based off of this, can you probably think of everything else? Following alphabetical order, the other ones are, of course, Q, R, S, and T. I do not know why they are called that, so please do not ask me. The questions are, of course, what happens in the P wave, what happens in the T wave, what happens in the QRS. So a reminder, moving forward as we talk through these things, the atria are in the upper chambers. Again, this is a helpful starter for looking into how the physiology works behind the EKG. Starting off, the P wave is where atrial systole occurs. Think back to what systole means. That means the atria are going to contract. Whenever the atria contract, the pressure builds in the atria, which in turn opens the AV valves, and that is what sends blood into the ventricles. So in the P wave, atrial systole occurs, and you can kind of see on the heart, I kind of drew what is happening, but atrial pressure increases while atrial systole occurs, and that causes the valves to open. The next essential thing to know is in the Q of the QRS complex, where the closure of the AV valves occurs, and this actually causes the first sound, the lub to the lub-dub of the heart. So that's what happens in the Q of the QRS, and we're going to move on to the middle of the QRS, right down the middle of the R. So imagine a line going through the R, and that will take us to the next step. The next major thing that occurs for our purposes is going to be ventricular systole. Remember, systole means contraction, and you can expect with contraction of the ventricles, pressure will build, and that will cause the semilunar valves to open. So we're opening the semilunar valves, blood is rushing into the pulmonary trunk and also the aorta. Whenever we look at the T wave, let's draw a line right after it, because what occurs in the T wave occurs right at the end before that flat line that you see. So in the T wave, you can ask yourself what occurs after something is in systole or contracts. And the natural thing to occur after that is for rest. So in the T wave, we experience ventricular diastole. You guys should not have to worry too much about atrial diastole, as far as I am aware. do not throw me under the bus, but I do not think you guys need to really know about that. But in ventricular diastole, something else also happens at the same time, and that is the closure of the aortic semilunar valve. The pulmonary one closes as well, but the biggest one for us is the closure of the aortic semilunar valve, because that causes the second sound, and that is going to be the dub sound. And whenever you look at the EKG up top, you can see that there is a flat line past the T wave. This, in part, is part of the refractory period in which the heart cannot contract. There is a time in the heart that it cannot contract, and if you shock someone, even if you hit someone hard enough, you can actually put their heart into cardiac arrest. You can put them into pure asystole if you put an electrical current into their heart at that time. So why did I keep mentioning that the atria are at the top of the heart and the ventricles are the chambers at the lower, more inferior part of the heart? The atria are superior, the ventricles are inferior. The reason why is, think about the natural flow of the heart whenever you're thinking about what is happening in the P, Q, R, S, and T parts of the EKG. Naturally, blood comes into the right atrium first. The top chambers are the atria. So to get to the ventricles, we first need atrial contraction, atrial systole. And then after that, you can finally have ventricular systole, where the ventricles contract and send the blood either to the lungs or into the aorta, into the rest of the body. So if you are finding it hard to make sense of what is happening in the P, Q, R, S, and T parts of the EKG, just think about how blood flows through the heart. It would not make sense for the ventricles to contract first before the atria, because they would not have been filled with blood yet. And also, please do keep in mind that the sounds of the heart are at the Q and right at the end of the T wave. The Q being the closure of the AV valves, the first sound, the lub, and the T being the closure specifically of the aortic semilunar valve, the dub, the second sound. If you need additional help to this, and it would be better to visualize both pressure and everything at the same time, I would highly suggest Google searching the Wiggers diagram, WIGGER' diagram. That is going to give you a picture sometimes of what the heart are doing in like a general, here's a picture of a heart sense, as well as the pressure buildup in the atria and ventricles, as well as the aorta actually, and volume, the difference in volume with the QRS complex and your whole ECG up top. So have fun studying. I know you won't have fun, but try your best, and hopefully this helps. If you need to watch it, rewatch it again. It's not too long of a video. This is just a basic explanation, but it should at least get you on your way to really doing well on your second lab practical. All right. Hope this helps everyone.